Oh, that's the equal? I hate this game.
Oh, did you go to Nerdle?
Yes, it's no good at all. It doesn't compute, man. Wait, 5, sorry. Okay, wait, what are the colors? It's the same as orange. There are 8 terms.
Check in with your neighbors. Are they getting the same weight for Austin?
Where does the X? Wait. There's a T next to the pie. I didn't see that.
14 days.
It's Wordle, but my brother. And there's like 2 different words in yourself, but like you have to use the same word. So like, yeah, but like
Once you figure out one word, then I don't even know.
yeah.
No, you're not. I guess it's 14 to 0.
It should be like
I
that.
don't know.
Okay.
Or like,
I got this. Cool.
so like there are 2 different words. Pretty cool.
Wait,
Then you have there like 2 separate words that you're using the same word. And you have to solve this.
I wrote that down.
Okay. I see what you're saying. I don't know what you mean.
Yes,
It's one of the best things.
All right, let's talk about this. First of all, who thinks they know how much Austin weighed 2 weeks before the season started? Matthew. Okay, this is totally make-believe. It just is great that Austin wrestles this weight. Okay, now, how do we figure this out? How do you set it up?
The total that you're trying to get
Mm-hmm.
equals the initial plus the.
Mm-hmm. Okay,
So I just subtracted the like function, the equation that was meant and put it.
okay, so this one's weird because we have the total weight, right? So we have the 132, and this equals our initial plus how much he's losing, right? So if we find whatever this amount is and take it over to the other side, that's how we get that 139. Is that how you also set it up?
Yeah.
Well, thank you, Kylie. You just what? Okay, so let's go back to yesterday and talk about the homework. Now, the answers were already on my website, on Google Classroom, so you should have checked them. Were there any that you had questions on? 5B. 5B, how many gallons of water are in the tank at time t equals 3? So we start out with 30. We are adding 8 gallons per minute, and we are subtracting our answer from here. Was that enough to get you? You just realized right there. So similar to yesterday, we are going to talk through a problem. And then I'm going to give you 2 AP problems for your homework. So just take a look at this packet real quick. Notice how the front page or the first page front and back, that's what we're going to do in class. And then the second page front and back are 2 free response questions that we will be grading. Okay. All right. So yesterday we talked about the total change theorem. So we had a rate and we use that rate in an integral to help us get the change. Okay. Well, now we are going to look at problems that have 2 rates, a rate in and a rate out. Okay. And these types of problems are very popular on the AP exam. Okay. They're very important. So let's go ahead and read through what the heck is happening. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by this. So this is remove, right? Now, after the store has been opened for 3 hours, store employees add bananas. They add bananas at this rate. Okay. Where G of T is measured in pounds per hour. So we're talking about 2 equations. They both are equations in the pounds of bananas per hour. Notice how this second equation is only defined from 3 to 12 because after 3 hours, that's when the workers start putting bananas back on the display table. So this is a 4-part question. How many pounds of bananas are removed? Find f prime of 7 and interpret it. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? And how many pounds of bananas are on the display table at time t equals 6? Okay, so let's just first of all break this apart. Okay, so rate in versus rate out. Okay, we are adding bananas using G of T. And what are the units for our rate in? Pounds, LBS, pounds per hour. Our rate out. So G of T is the workers putting bananas on the table. So we're adding bananas. F of T are the customers removing bananas. So our rate out is this function, F of T. Also in pounds per hour. How many pounds of bananas did we start with? So we started with 50 pounds of bananas. Is anyone trying to like figure out how many bananas would be 50 pounds? That's a lot of bananas.
That's like I keep.
Right? So we're talking about like 50 bunches. Okay. Open that can of worms. That was my fault. Sorry about that. Okay. So let's talk through each of these questions. So in part A, they are asking us how many pounds of bananas are removed during the first 2 hours. Okay, well, actually, this is what I'm gonna have you do first. Everybody get out your calculator. Everyone get out your calculators, and what I want you to do is I want you to put F in Y1, and I want you to put G in Y2. That way you only have to enter them into your calculator one time, and then you can just use that alpha shortcut to call up Y1 and Y2. Let's just go ahead and make our lives easier right off the get-go. Although you are done typing these two functions into your calculator, when your calculator is on your desk and you are not holding it. Okay, so part A. Part A is asking us how many pounds of bananas are removed from the display, okay? So we know that our rate out equation is F, all right? And if they're asking for the first 2 hours, what do our limits of integration need to be? So from 0 to 2 of our function F, okay? Now, luckily in your calculator, you can just call up Y1 now, but in your calculator, please compute the integral from 0 to 2 of function F of t dt. How many bananas are removed? How many pounds of bananas, excuse me, are removed in the first 2 hours? Alpha F4 is that shortcut.
What's your Y1?
Ten plus. Makes difference. Okay. Now, let's go ahead and turn to the next page. Okay. So part B is asking us to find f prime of 7, use the correct units, and explain the meaning of f prime of 7 in the context of the problem. I have an issue that I didn't get fixed, I guess. Please make these f of t, not f of x. Sorry about that. Okay. So if the calculator is in your hand, please do not find the derivative with a pencil. Okay? With your calculator, please use math 8 and find the derivative at 7. Now, function f, that's what I put in my y1. So I'm gonna say math 8 of function f evaluated at 7. Negative 8.120 is what you should be getting. Ooh, yes, let's think about this. Okay. You don't understand what?
I understand this.
Okay.
Just something else. Unrelated.
Okay. So, okay, I have a question, and we wrote this on our first page. Okay, what is the units for F of T? Pounds per hour. So the derivative would be pounds per hour per hour. So our derivative would have a unit of pounds per hour squared. So now we have to interpret the meaning, okay? The rate. We took the derivative, so we're talking about a rate. The rate at which bananas are being, we're talking about F. F was our rate out, removed from the display table, is decreasing. We are choosing decreasing because our derivative is negative by 8.120 pounds per hour squared at time t equals 7 hours. Isn't that nice?
Whenever we have to interpret, you want us to like use this format.
I think this would be a good thing to look at, yeah. Because we're talking about a rate. You have to talk about if it's increasing or decreasing. You need the value with the label, okay? All right, so now the good stuff, part C, is the number of pounds of bananas on the table increasing or decreasing at time t equals 5. So here we go. And this is where we really have to like wrap our head around the idea that our functions are rates. Okay. So your function is bananas per hour. Okay. What is f of 5? Okay. And remember, this is pounds per hour. Okay. This is a rate. Okay. So we are removing bananas at a rate of 13.796 pounds per hour. When we plug in G of 5, and remember, G is pounds per hour. Okay. So this, remember, function F is our removing bananas. Function G is our adding bananas. So is the number of bananas, excuse me, is the pounds of bananas increasing or decreasing? So at time t equals 5, the number of pounds of bananas on this display table is decreasing because f of 5 is bigger than g of 5. So bananas are being removed at a faster rate they are being added. Okay. Since the rate of removal is bigger than the rate of adding, the bananas are decreasing. Okay, now look at this note over here. Oh no. Look at the little box to the right. Why are we computing f of 5 and g of 5 and not f prime of 5 and g prime of 5? Our functions are already rates, so we can just take them at face value. Okay. All right, part D. How many pounds of bananas are on the table at time t equals 8? Okay, what is a keyword that can help us understand what we need to do? Pounds. Okay, so here's what we need to keep in mind in problems like this. We have an initial amount. We are adding bananas. We are subtracting bananas. So how many bananas did we start out with? We had 50 pounds of bananas. Plus, starting at time t equals 3, we started adding bananas. Minus the removal of bananas. Why is 8 my limit of integration? Okay, because t equals 8, so I'm using 8. Okay, so in your calculator, you need to find how many pounds of bananas we have on our table. Gut feeling, more than 50, less than 50. Okay.
Oh, it's like,
Gwen, did you get an answer? Okay. Winner has an answer?
yeah.
What'd you get? Agree? Less than half of what they started with. Yeah, but have you ever gone to a grocery store like Saturday or Sunday afternoon? The shelves get picked over, especially Target. Target is no, especially like the bean aisle for some reason. I can never get chili beans when I need them at Target. Okay. Now, something that we experienced at the beginning of class. The units are important in these problems. Sometimes you get a 9th point just for having all of your units correct. Okay. Now, do you remember yesterday when we skipped a couple problems because I was like, ooh, we need tomorrow's lesson? Okay, let's go back. So I want you to go to the total change theorem, and we're gonna go to the number 5 on the in-class work. So we had like the unprocessed gravel. Okay, so on a certain work day, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is this. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So this is unique. We have a constant rate for this. Okay. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5? What are we gonna have to do? Okay, we need G of 5. Find me G of 5. Did you get Isaac? Okay, so that is our rate for unprocessed gravel arriving. What is the rate for processed gravel leaving? Okay, so how does this compare to 100? It's smaller. Okay, so our answer is decreasing. Okay, the rate of unprocessed gravel arriving is less than the rate of gravel being processed. And this is where the fun begins. Part D. What is the maximum? Ooh, maximum amount of unprocessed gravel at the plant during the hours of operation. So let's first of all just talk about the equation that represents how much gravel we have. Okay, I'm going to call it A for amount. How much do we start with? 500. And then we are adding the integral from 0 to t of g of x dx. And then we're subtracting the integral from 0 to t of 100 dx. Okay, this represents the amount of gravel at any given time. I want the maximum. What do? I want a maximum. Take the derivative. Okay. How do I figure out where my derivative, bless you, equals 0? I can't hear you. Okay, how do I figure that out? You really want to solve that? I would put G of t minus 100 in y equals and figure out where it crosses the x-axis. You have that capability, right? Okay. You have the capability of figuring out where you have a 0. Remember, second, calculate 0. You do minus 100. Okay. So if you punch in G of t minus 100 into your y equals, we can figure out where it equals 0. I bet it's between 0 and 8. It better be, right? Use second trace to calculate the 0. Should get 4.923. No. Oh, there you go. Okay. Okay, so go back to my equals. Put in the minus 100.
Oh, that's right. That's that one, right?
You did 6. I don't know why you're so far out. And then I want you to find that. Okay, now here's where almost 90% of people will lose points on the AP test on this problem. I don't know, that's totally made up, maybe 80%. We have a value that's our critical point, but we have a closed interval. When I ask you for a maximum or a minimum on a closed interval, what do you have to do? You have to plug in the endpoints and you have to plug in the critical points in order to figure out which one actually is the biggest. Okay. This is the equation you'd be plugging into. Now, the good news is this one's easy to find. When we plug 0 in, we know that we started off with 500. So what you would need to do is you would need to plug in 8, which actually wouldn't be so bad because we have this right here. Okay, but you'd need to plug in 4.923. Okay, now I'll help you out. Okay, here is our maximum. If I plug these values into this equation right here, I'm finding the biggest value. Now, if we did not have a closed interval, we could use the sign chart plus minus. Cool. But since we have a closed interval, we actually have to test the end point and the critical point. Okay. I don't know, this may or may not happen in one of your homework problems tonight. So if you have a question, ask now. Can you use your calculator? Do you remember how to graph, how to find a 0 with your calculator, how to use those y1, y2 shortcuts so you can type in an integral without having to type in the entire function? Some of these things are convenient things, but I need to make sure that you understand how to use your calculator. Okay. Now, you have 2 free response problems, both of which require you to have a calculator. Let me remind you of some things. If you are doing some sort of integral, like look at what we did in B. If you only give me the answer, you will lose points. If you type something in your calculator, show me what you typed in, that way I know. Okay. Show me what your derivative is that you set it equal to 0. Here's the critical point. Okay, you need to do both of those free response problems on the pink packet. Okay, there will not be answer keys online. This is something I want you to do on your own. Okay, have them ready for me tomorrow.